Knowing what to do when is the hard thing. It is the hard thing about integrals. So this last one we did, we saw it was e and sine. So that was the type 3 integration by parts. So let's look at this one. This one has cosine and sine. They're not both even powers. So this is the type we want to make a good du. We want to leave even powers, and the identity we're going to use is the sine squared of x plus the cosine squared of x equals 1. So looking at this, I want to peel off a sine because that would leave even powers. So sine squared, and that gives me a sine x dx. Okay, so this is my du. So du is sine x dx. And then u is, this is what I call the negative issue. We've never let u equal a negative cosine if there's no negative in the problem. So if u is cosine, there would be a negative there. Oh, but let's just take that negative away, and then let's put the negative right there. This is the easiest way not to make any mistakes. So now I want to make my u equal cosine work. Okay, so u equal cosine works there. The du takes care of that. How am I going to deal with this? Oh, right. That's where we use this identity. So then I'm going to keep the cosine squared. I'm going to rewrite sine squared as 1 minus cosine squared, and then sine of x dx. So it's really important to keep all x's and then go all u's. So this will give me u squared, 1 minus u squared, and then a negative du. So I'm going to pull the negative on the outside, and then I get negative, well, hold on a second. Sorry about that. Not that. So multiplying it out, being careful. Okay. So if I multiply 1 times the u squared, that's u squared. And then here, I get a minus u to the 4th, du, right? And that negative came out there. So negative is out here. Oops. And then I'm going to take the antiderivative, so I don't write the integral sign anymore. So then I say, okay, so that's u cubed over 3 minus u to the 5th over 5 plus a c. And then you put the u back in. So negative 1/3 cosine cubed x. And I'm just going to distribute this, not necessary, but I'm just going to do it, u to the 5th, and then plus a c. All right. So then let's look at this next one. So number 5 had sine to the 5th. Okay, since it's an odd powered sine, it's not even, so you can't use half angle formula. You want to peel off to make a good du. All right, so let's peel off a sine. It's very much like the last one we just did, right? So sine to the 4th x, sine of x dx. Okay, so I know my du is sine of x dx. So that means my u is cosine. Oh, that's right, it's the negative issue. So I'm going to put the negative right there, because derivative of cosine is negative sine, but I'm going to put the negative right there. All right, so then I want to make u equal cosine work. Okay, let's make sure we know what that means. So this is the same thing as saying sine squared squared sine of x dx. So now I want to replace sine squared, so I can use this u as 1 minus cosine squared all inside the squared sine x dx. So notice I have all x's. Now I'm going to go all u's. So take out sine x dx and put in a negative du. And then I'm going to put a 1 minus u squared squared. And so now I'm going to take that negative on the outside, multiply this out, minus 2u squared plus u to the 4th, and then finally take the antiderivative. So that gives me u minus 2/3 u cubed plus 1/5 u to the 5th plus c. And then what was the u anyway? Oh yeah, the u was cosine of x. So I will put cosine of x minus 2/3 cosine cubed plus a 1/5 cosine to the 5th x plus a c.